We want to prove the identity 1 plus sine theta plus cos theta all squared is the same as 2 times 1 plus sine theta times 1 plus cos theta. If we start by looking at the left-hand side, we need to expand out this bracket. We could use a grid to do this. If we draw our grid, and it will need to be 3 by 3 since we have 3 things in our squared bracket. We have 1 plus sine theta plus cos theta, and down the side 1 plus sine theta and plus cos theta. 1 times 1 gives me 1. 1 times sine theta gives sine theta. 1 times cos theta gives cos theta. 1 times sine theta gives sine theta. 1 times cos theta gives cos theta. Sine theta times sine theta gives sine squared theta. Sine theta times cos theta gives sine theta cos theta. Cos theta times sine theta gives sine theta cos theta. Cos theta times cos theta gives cos squared theta. Taking out of the grid, we've got 1. We have 2 sine thetas. We have 2 cos thetas. We have 2 sine theta cos thetas. We have a sine squared theta. And we have a cos squared theta. The sine squared theta plus cos squared theta is 1, so we can add 1 to this one, giving us 2 plus 2 sine theta plus 2 cos theta plus 2 sine theta cos theta. So we now know the left-hand side is 2 plus 2 sine theta plus 2 cos theta plus 2 sine theta cos theta, and taking out a common factor of 2, we get 2 times 1 plus sine theta plus cos theta plus sine theta cos theta. If we now consider the right-hand side, the right-hand side is 2 times 1 plus sine theta times 1 plus cos theta, and we can expand these brackets. We've got 1 and sine theta, and 1 and plus cos theta. This gives me 1 plus sine theta plus cos theta and plus sine theta cos theta. So this becomes 2 times 1 plus sine theta plus cos theta plus sine theta cos theta. And note that this is the same as what we got above. So we've proven because the left-hand side has become the right-hand side, or at least they've met in the middle.